Didn't we all write on the very bottom of part A, the raw score of something over 54, right? And then we have potential. And these we're going to write out after the whole FRQ is done. And then you have 2 grades for the first one and the second one. Add a 9 for the raw. What did you get before I went over? And what would you get after I go over? Y'all ready? Is that screen open? Is it closed? It's closed. Very good. All right, Charlie, go ahead and read number 1 and the whole scenario of that specific box.
A particle moves along the x-axis so that its velocity at time t is given by v of t equals that equation. At time t equals 0, the initial position of the particle is x equals 7. Find the acceleration of the particle at time t equals 5.1.
So the initial position we don't really need, but we're going to need it at some point, somewhere on the back. So let's write x of 0 is equal to 7. And then what I want you to do is look at flashcard number 5B, and I'm going to explain. Eyes on the board. On the board. I give you velocity. So the derivative of that is the acceleration, correct? So if I give you velocity, the integral of that must be position. Give me a nod. Okay? So with that said, let's take a shortcut. I want you to type this in Y2. We're going to use that vars. Y1 save, we might need it on part B, on Y2. Because your whole point on your AP test is to make sure you are not wasting time typing tedious things in over and over and over. Oh, y'all see what I did? Alpha y equals. Oh, man. I tell you to not waste time, and here I go, doing that exact same thing. And then we have plus 12. Are we all typing with me? Yes. Plus 3. So again, quick reminder. FRQ number 1 and 2, you'll need a calculator. Okay, so from there, let's write out 3 things. My acceleration is the derivative of the velocity. Write that out. And what they gave us was velocity or acceleration at time equals 5.1. And if y'all remember the calculator trick, to find the derivative, it was math number what? Was it 8 or 9? 9. Ooh, 9 was the integral. It's got to be 8. So let's practice this together on the home screen. So go to math, 8. It should give you that, the derivative. And then the function, you don't have to type it in. Didn't we already save it on Y2? So let's see if y'all remember how to recall this. We go to vars, and then where do I go? Y var, and then I go to function. And then we put r's in Y2. And then it says it wants it at 5.1. Everybody must be typing. And then when I press enter, we get this number. So I'm going to write 6.492. Now, typically, it might say describe the reasoning, not the reason, the answer. So I'm going to assume that we have to write a sentence. Because the more you write, the better it is. Okay? So I'm going to put, let's underline where I'm going to use my sentence stem. So using the sentence stem that they give us is always good. So we have the acceleration. Everyone's writing. Of the particle at time t equals 5.1 is the answer we got, 6.492. So when you're taking the AP test and you're like, it looks kind of empty, maybe write a sentence, okay? Writing more is not going to hurt you. So then let's look at our point system. There will be 2 points. There's only 2 points, actually 1 point on this one. Finding the acceleration of 6.492 is going to be 1 point, only because it was strictly using the calculator. Okay? Could we all get that at least? Find the derivative, hopefully. Again, saving your y value into y2 is always clever. Okay, let's go on to my second one. Cooper, let's read part B.
Find all values of t in the interval p is less than or greater than, 0 is less than or greater than t is less than or greater than 2, for which the speed of the particle is 1.
All right? So if you look at card number 10B, the speed of the particle is always what of the velocity? Always the absolute value or the magnitude. They mean the exact same thing. So I'm going to put on here, our speed of the particle is always the absolute value of the velocity. So because I want to know when it's going to reach 1, I'm going to actually use y1, set that equal to 1. y2 we already have. So I'm going to use my velocity with the absolute value. Ooh, I wonder if I can plug in the velocity. I believe I can do something. I'm going to see if that works. Okay. I'm going to get a little bit creative on this one. Y'all know how I already typed in the velocity into my y2, right? So then you're like, well, how are we going to graph it? Well, there's a way. Go to y1, type in 1. And then here's what I want you to do. I want you to go to y2, highlight the equation, and deselect by entering. So what that's going to do is, I'm not going to graph that piece, but on y3, I think it's going to work out. When you go to math, and then number, it gives you the absolute value. And I believe I can use the vars and y vars and recall y2. Let's see if that works out. If it doesn't, we'll need to be kind of tedious on that one, but I feel pretty positive about this one. So because y1 and y3 is highlighted, it's only going to graph those two. Is everyone good with that? So again, work smarter, not harder, right? And then what I will do from here will be, since our window is from 0 to 2, why not go to our window? And y'all should be at 10 by 10, hopefully. And because I'm looking at these two intervals, I'm going to make it start at -1 just to see the boundary. And I'm going to make it end at 4. If you want to make it end at 10, that's okay. And let's see if it would graph. So here's my 1. And here's my other graph. And I'm hoping to find that it's going to intersect at some point, once or more than once. And that is more than enough. So let's see. Do y'all agree it's crossing right here and right here? Between 0 to 2? So let's do second calc, 5. And I'm going to hover to the first intersection. And you press enter 1, 2, and 3. Okay, in case you're not familiar with the keystroke, I want you to write out second calc, the number 5, and you have to hover left or right depending on where the cursor is, and you press enter 3 times. So the first one that I entered, and I'm going to make that into 3 decimal places, we have 0.772. Let's find the other one. Second calc 5, go to the right side of it, enter 3 times, and that's going to give us 1.4. And I think I want to be a little more specific. If I were to use my rounding tool, it'll be 1.40 what? 401? Because after my 2 zeros, I have that 5. I'm going to use my math. Okay, so then we have extra room. So let's go ahead and write out in sentence. So we have the speed of the particle. The speed of the particle is blah and blah. So the speed of the particle is at times, the first one was at 0.772. Ooh, 772. And t is equal to 1.401. And then our point system. Knowing the velocity, absolute value of the velocity is the speed as our 1 point. And your final answer is going to be another point. So again, when you have that extra blank space, what do? Write it in words. Y'all good with that? And copy off the sentence then from the original question. Okay? So let's go on to part C. Part C is going to involve a little more brain power, not only because we're using 2 flashcards, but only because we need reviews on a lot of the, I think, card number 6B. Right, Kendall, let's read part C.
Find the position of the particle at t equals 4. Is the particle moving toward the origin or away from the origin at time t equals 4? Justify your answer.
Okay, I'm going to bust out my 2 of them. The first one, my particle is moving away if it is what? Positive. My particle is, when it's negative, it is getting closer. Do we see that? Okay? Y'all good with that piece? The next piece that I want you to take out is our flashcard number 6B. We're going to use either one of them. Okay? So I'm gonna kind of reiterate in case some of you guys are like, well, the flashcards are still kind of hard to understand. So when you integrate the derivative, don't they cancel each other out? Right? That's why it's got just the f. Okay, so the way to look at it is derivative of the f is f prime. Derivative of the big F is a little f. Okay, they mean the exact same thing. I like to use the second one. Okay, so on this one, we're looking at t is equal to 4, and I want to figure out the particle. Because it's a particle, and I gave you the velocity equation, I need to go backwards. So I want you to put on here, the position is the integral of the velocity. And then I want to go ahead and use the formula on this one. So we know our velocity is starting at 0, and I'm looking at it from 4. Everyone see where I'm getting the 4 from? Time equals 4. And I'm going to mimic this formula right here. So we have velocity. So here I go. The velocity, and then integral of velocity is acceleration. So that means our acceleration is denoted by our x value, x of 4 minus x of 10. 0. Put them all on my desk, everything, including original. So I'm going to repeat myself one more time. Derivative of f is f prime, correct? Derivative of the position is velocity. Give me a nod if that made sense. Okay? So then I'm going to plug in what I know. What they gave us is the integral. Actually, I want to make x of 4 by itself. If I make x of 4 by itself, I'm simply going to move this guy over here, which is going to look like x of 0 plus the integral. And we're applying algebra for that piece. And I forgot dt over here. Now let's plug in what I know. From part A, what was the initial value at x of 0? 7. And then the next piece, we have the function already saved in y2, so why not go ahead and recall that by just writing out v of t, dt. So let's all type this in together. Go to your home screen. We're starting with the initial value of 7 plus. So if the derivative was math 8, what was the integral? Math 9. Everyone go to math 9. And I see 3 of you guys not typing in. So we have 0 to 4. And I'm going to recall vars, y vars, the function. I saved it in y2. And then dx. So let's see if the particle at time equals 4 is positive or negative. It's taking a while for the integral. Did y'all get 6 point something? Okay, let's write on here. This value is 6.712. All right, do I have a lot of space again? Blank space. Yes, I do. So let's go ahead and write out something. Let's underline which sentence stem I'm going to steal from. I'm going to say the particle is moving because it's positive. Is it away or towards? Away. From the origin at t equals 4. So I'm going to write all that down. And I'm going to explain what this means. So we have the particle is moving away from the origin. Can I use the word it? Could I ever use it or that? No. Origin at time equals 4 is going away because the value we found is positive or negative. It is what? Positive. So I could say the word positive or I could say greater than 0. They mean the exact same thing. So the way they're going to give you the points. Knowing the initial value right here is going to give you 1 point. And then your integral piece over here, right here, it's going to give you another point. And your explanation, or having that is a positive number, is going to give you another point. But if at all possible you have white space, go ahead and write it in words. It's not going to hurt you. Okay, give me a note if that makes sense. All right? Now let's go on to part D. Part D is going to use our flashcard number 6B again. Okay, Molly, go ahead and read that piece.
During the time interval 0 is less than t is less than or equal to 4, does the particle return to its initial position? Give a reason.
Okay, so here's what's happening. At time equals 0, we're at the position of 7, correct? So if I have a number that's bigger and smaller, is it going to go through that number one more time at some point? Or the other way around? So I need to figure out where can I find another value that's going to be maybe greater than 6.712. Y'all see that? So if I have 6.712, right above it, it's gonna be 7, and I need something, number a little bit more above that one. So you have many options, and I haven't tested this part yet, just because I knew what the final answer was. You can test x of 1, x of 2, x of 3. Do I need to test x of 4? We already have that piece, correct? Let's do the 1 and see what happens. And this is flashcard number 1B. If I'm looking at between this, what does flashcard number 1B say? The what value theorem? Intermediate value theorem, yes? So let's see the condition 1. What do I have to state? That the function is continuous on the interval given. The interval given is this guy over here. So you don't have to be like, do I have to put a bracket or not? They'll give it to you. So let's say x of t is continuous on the interval 0 to t less than or equal to 4. And again, I already have 4. So I'm testing 3, 2, or 1. I'm going to test 1. So let's put on here, we have x of 1. And to use the theorem, let's use our flashcard number 6b. We have the integral from 0 to 1 of v of t is equal to, dt, is equal to x of 1 minus x of 0. And my goal is to make x of 1 by itself. Applying algebra 1, x of 1 is equal to x of 0 plus the integral. What was x of 0, everybody? 7. 0 to 1. I wonder if I can recall and take a shortcut on the calculator. Y'all try it with me too. See if you can select going up. Press enter. And the only thing I'm going to change here is which bound? Upper or lower? My upper one. Kind of nice, right? Press enter. And that's going to give us 9.404. So if I have 9 point something and 6 point something, am I going to get to the initial position of 7 at some point? Right in between. Yes, we can. So I'm going to go ahead and write on right here on something. I think I want to also say from part C, x of 4 that we got was 6.712. Because we noticed between these two numbers, the intermediate value theorem does happen. So let's write out our reasoning. By, I'll give the reason, this one needs a sentence. By the IVT, the particle returns to the original position, and I think I'm going to write x of 0 is equal to 7. From time t equals 1 to when? Somebody tell me the other. T equals 1 to what 2 did I compare? 4. Because, and I'm going to write the, I think I'm going to do the interval notation. 6.712 is less than 7, less than 9.404. So as long as you get the main idea of this, you're good, okay? Again, don't use that, don't use this, and so on. So then, testing out another value is going to be 1 point, and that other value must be greater than. And then stating the IVT and the whole condition is going to give you another point. And let's tally and make sure I had all 9 points so far. So that's 3, 4, 5, 6, 7, 8. Am I missing a point somewhere? Okay. Oh, I see. The missing point is this guy over here. Getting 6.72 is 1 point, and then the explanation is my next point. So let's tally again. C has 4, D has 2, that's 6, 7, 8, 9, perfect. So on your 1A, I want you to write, what was a raw score before I went over? What was your potential now that you have all the knowledge?